Today, we're going to get started on acceleration. I haven't posted for a week, and that's because I've just been very busy with university. But I'll try being more consistent and posting more videos weekly. Uh, we're going to get physics out of the way first, and then we're also going to move on to some math soon. So we already covered vectors and velocity. Now we're gonna shift our focus to acceleration, which is really like a building block for the rest of physics, especially when you go into forces. We're gonna be using a lot of acceleration when we go into dynamics and forces. So what is acceleration? In the previous lesson, we learned how velocity was a rate of change of position. So a recap, velocity was position graph over time graph, a rate of change of position. That's my bad, but rate of change of position, like this rate, the slope, was our velocity. Now, acceleration is going to be the same thing, except instead of rate of change of position, we have time on one end and velocity. So let's say this uh, graph, on this graph, over time, this person is just traveling 1 meter per second. He's at a constant velocity. This velocity becomes an acceleration. Sorry. This velocity becomes an acceleration once once there's a slope. So same as the position versus time graph. Now we're gonna work with the velocity times time graph, velocity over time graph. And in the same way we did it previously, where we did rise over run to find the slope. In that case, rise over run was distance over time. In this case, our rise is going to be velocity. So our rise is going to be velocity, and our time is going to remain the same. So we're going to have velocity over time this time. And this is going to equal to our acceleration. This is the formula we're going to use for acceleration. So uh, let me just dumb that down a bit more. A equals change in velocity. The triangle, this right here, means change. So difference. So final velocity versus initial velocity. Same thing as displacement, how we wrote the triangle with the D. We're going to write the triangle with the V. Over change in time. Or, well, you could write it like this. We could just write it just like this as well, because right now we're in classical physics. Time is just going to go on like 1 second, 2 second, 3 second, whatever you write. It's going to be the change in the time. If the acceleration was happening over a certain time, so starting from 5 seconds and ending at 6 seconds or ending at 7 seconds, then you use that interval and your time is going to be 2 seconds. It's going to be the difference between, it's going to be your time interval, is what the denominator is going to be in the situation right here. So this is the formula you come up with from rise over run. It's going to be velocity over time instead of distance over time, and you have change in velocity over time as your formula. So hopefully that explained what acceleration is a bit. But there are some other factors to the definition of acceleration, other than it's just a rate of change of velocity. There's some things that we need to understand. Acceleration is a vector quantity. Oh, acceleration is a vector. Let's write this a bit smaller. Vector quantity. And we all know what vector quantities are. We know what vectors are. Acceleration has both magnitude and direction. There's no version of it that we're going to get into right now that doesn't include a direction. We're going to work with acceleration as a vector and vector only. The magnitude of the acceleration is measured in meters per second squared. Only the seconds is squared, meters is not squared. Okay. And now, actually, let's talk about why it's meters per second squared instead of just meters per second or meters squared per second squared. The reason it is meters per second squared is we're gonna look back at what velocity is again. Rise over run of the velocity over time. So time, velocity, the velocity goes up, that means there's acceleration. Rise over run, which means v over t, well, change in v over t. And what's the units for velocity? We're gonna move just units here. Meters per second over second, because time is seconds. Now we can move this down, and we're left with meters per second squared, and that is our unit for acceleration. Now, the direction of acceleration is a bit trickier of a concept to grasp. So let's do an example. Let's say there's a car. We'll start with something easy. There's a car, and it goes from 0 kilometers per hour to 100 kilometers per hour over this distance, which is in the direction of east. This car, the acceleration is in the east direction. Okay? Now, let's say things get a bit complicated. Uh, he sees a deer on the road, and his velocity goes to 5 kilometers per hour from 100. Now, he's still going right. He's still going in the east direction. The velocity is still in the east direction. But since now the car is going from 100 kilometers to 5 kilometers per hour, the acceleration is in the opposite direction. Let's do a different color. The acceleration is in the opposite direction of the velocity because he's decreasing in velocity, right? The velocity's slowly changing directions back to west. That is our acceleration direction, west. It's going to be the change in the direction while the velocity is still towards the east over this course. It's still towards east, but the acceleration is in the opposite direction. So direction follows which direction the change is happening in. Okay? And acceleration can be caused by multiple things. Um, well, like it has to be caused by a force. Acceleration is always caused by a force. Everything is technically at rest when it's not under a force or when it's not being accelerated. So like even like a person moving at 0 kilometers per hour, his acceleration is zero until someone pushes him, and that acceleration and the person starts getting accelerated only with a force. And there's different forces that can cause acceleration. There's gravity, friction, gravity being the acceleration that pulls an object towards another massive object. On Earth, that rate is 9.81 meters per second squared. Earth gravity acceleration. And there's also friction, which opposes the motion of what the object is going in. So let's say you're trying to slide a wooden block over a carpet. You're gonna have a very hard time doing it because there's a lot of friction, which means there's a lot of opposite force or opposite acceleration from the direction you're trying to push the object in. And that friction force is a lot less when it comes to, like, let's say moving a block of wood on ice. But we'll get more into that um in the next like forces unit when we cover it. Um but yeah, acceleration is a very important concept in physics, and it describes the motion of multiple objects. It describes the motion of star systems, galaxies, particles, planets, and we're going to use acceleration a lot throughout our physics career. And it's very important that we understand acceleration because acceleration is the force. Is it like a signature of what forces are at play on an object? Whether again that be a star system, planet, particle, rocket, whatever it is. So a slope in the velocity graph indicates slope. It's very bad handwriting. Slope in velocity versus time graph indicates acceleration. And for the acceleration, we're going to use a with a arrow on top of it because acceleration is a vector. So let's move on to some practice questions. So here I drew three questions, three graphs where we are gonna figure out which of these graphs have acceleration and which don't. Let's start with number one, right over here. Number one. So we see that we have a velocity over time graph, right? But our line is a straight line. Now, what did we say about straight lines on a velocity over time graph? It's just velocity, it's a constant velocity, there's no acceleration. On here, there's no acceleration. Okay? No A. There's no acceleration. On number two over here, we have a velocity over time graph again. But we see that there is a jump down in velocity. Now, what does this mean about our acceleration? We know that our acceleration formula is final velocity minus initial velocity over time. So change in velocity over time. Was there a change in velocity in this graph? Yes, there is a change in velocity, and that's right over here. This velocity clearly changed from whatever this value is. Let's say it's 2 and this is 1. It clearly went from 2 meters per second down to 1 meters per second. So yes, there is a acceleration. It's in the negative direction because it did go down instead of going up, but there is an acceleration. So there is an acceleration. Number three is a bit trickier. Here we don't have a velocity. We don't have a velocity over time. We have position over time as our graph. Now this graph is a bit weird. It's not a linear line. This is a parabolic shape. Now what does that mean for our acceleration? In a position versus time graph, we know that if there's a constant slope on this graph, that there is a velocity. The parabolic shape means that there's there's a change in position, yes, but that position is also changing how quickly it changes position as well, which means that it's changing how quickly it changes its velocity as well. So we know that the velocity is changing in this, so that means that we do have acceleration. And if this part's a bit harder to understand, I'm not sure if I explained that well enough. If there's any other questions you guys have on this, you can write it down in the comments and I will respond to it as well. Let's move on to some calculation questions. Let's say we have Guy again back in our video. Guy is standing over here. He's not moving a muscle. Okay. Now Guy starts running. Starts running. Let's draw a quick. Guy running. So Guy starts running and he gets up to the speed of 15 kilometers per hour. Let's just do meters per second. It's a bit easier to understand. Guy is very fast. He's running 15 meters per second. Okay. What does that mean for our calculation? How do we calculate how fast he's moving? Let's say he does this over a 10-second a 10-second interval. Let's get our formula. We know that it was rise over run, and we took rise over run and we turned it into a different formula, which was acceleration equals change in velocity over time. Change in time. We know it took him 10 seconds over this entire interval. 10 seconds. So let's input all these numbers. What is the change in velocity? Change in velocity is just the final velocity minus the initial velocity over however much time it took. In this case, it was 10 seconds. There's time. And now let's input our values. We have, as our final velocity, we have 15. Sorry, just give me 1 sec. 15 meters per second. And our initial velocity was 0 meters per second. And our time interval was 10 seconds. So let me just calculate this real quick. 15 divided by 10, 1.5. Our acceleration, Guy accelerated 1.5 meters per second squared in the right direction. Now, let's change this up. Okay, let's fully change this up. Let's say Guy was running, but he started getting tired, so he started running a bit slower. So at this point, Guy's back to walking. He's back to walking. So his speed went down, velocity went down from 15 meters per second down to 5 meters per second. And he doesn't have a lot of stamina. It took him 3 seconds to lose his stamina and start walking. Now, how are we going to calculate this? We're going to do it. We use the same formula. Acceleration equals change in velocity over change in time. Vf minus Vi. Be sure to show your work when you're doing these calculations. It'll help you understand what you're doing, and it'll also help your teachers understand what they're grading. The more steps you show, the better marks you'll get, essentially. So his final velocity is 5 meters per second. And his initial velocity was 15 meters per second. and the time interval he took was 3 seconds. Now, we're going to end up with a negative number here because we're subtracting a smaller number with a bigger number. Negative 10 meters per second over 3 seconds. That's a bit weird. Why is that? Still going right. He's still going in the east direction. So why is his velocity over here negative? And why is our acceleration going to also come out to be negative? Why is that? That is because our velocity, yes, it is in the east, but our acceleration is going to be in the opposite direction because he is slowing down. He's not speeding up, he's slowing down this time. Put that in the calculator and we get 3.33, and the 3 is repeating, meters per second squared. In this case, we'll just round 3.33 meters per second squared. And that is our final answer. Let me do significant numbers, which, if you guys don't know, I'll explain it in another video if you guys want. Significant digits is very important when it comes to physics. When you're calculating, while you're doing the calculations, you don't really want to use significant digits, but when you're presenting your answer, you will be required to present significant digits for multiple reasons. One being that it's just convenient, makes things easier to read, and you will lose marks if you don't. If a test ever happens and you decide not to put in your answer significant digits, you are going to lose marks on that test. So our answer is 3.3 meters per second squared. And this is negative because we had a negative in the change in velocity. Now, negative acceleration just means acceleration in the opposite direction. We don't want to say that it's slowing down when we see negative acceleration. We don't want to say it's slowing down because it might eventually be speeding up in the opposite direction. We never know. We're just gonna give the direction. We're not gonna say it's slowing down. Sixth acceleration, just in a different direction. So in negative 3.3, we'll just say our positive was east, our negative is west. So negative 3.3 meters per second east, or if we're taking it in terms of west, we're just going to write 3.3 meters per second square in the west direction. And that is our final answer. And again, if you guys have any other questions at all concerning this topic, or if there's anything you want me to explain a bit further, just leave it in the comments. I'm very, very open to suggestions. And again, if you guys have any practice questions, also just email me or leave it in the comments, and I will respond with a short or a TikTok, just going through the question and explaining whatever you guys still need help with. But yeah, next lesson is going to be dynamics. We're going to start learning about forces, and that's where things get a lot funner. Or actually, before we do dynamics, we should probably do parabolic systems. Parabolic systems being like if I throw a ball and it goes like in an arc like this, we're gonna do those first, and then we'll move on to forces. But yeah, if you guys have any questions, just leave it in the comments, and I will see you at the next tutorial.